The question are, a group of researchers is to analyze survey data on and to construct confidence intervals to estimate population parameters, such as mean and variance for both single populations and comparisons between two populations. The data is given as follows. Question 1. Estimate the mean of a population and construct a 1 minus alpha% confidence interval for these population parameters. Hence, A. Find a 95% confidence interval for the mean of a population, and B. Interpret the results. The population that we chose is hours of study when the n is 12. First, we can find x bar and standard deviation using the formula or directly from calculator. Since the variance is unknown and the n is less than 30, we will construct using the t-distribution. First, we have to simplify the equation to make mean as the subject until you get this. To answer the question A, we need to find the alpha for 95% confidence interval. Alpha equals to 0.05. Now, we can substitute the x bar, alpha, and s value in the equation, and then solve it until you get mean. We are 95% confident that the true mean number of hours studied by the population lies between 14.1833 and 20.3167.
Estimate the mean of two populations and construct a confidence interval for the mean difference of two populations. Hence, A. Find the 95% confidence interval for the difference in mean of two populations. Interpret the result and discuss your findings about the interval. The population parameters that we choose is class and test score. For this, we need to divide the populations by class A and class B. Using calculator, we can find the n, x bar, and s.
The rule states that if the larger s squared over a smaller s squared is less than or equals to 3, then the variance squared can be determined by the pooling of the two variances.
First, you need to find the value of SP by using this formula, and we get 13.2786. Then can construct the mean interval. To calculate A, the 95% interval, which means the alpha is 0.05. We can sub the x bar, find this value in the t-distribution table, sub the SP that we found just now, and then this would be your final answer. To answer question B, we are 95% confident that the true difference in mean test scores between class A and class B falls between -23.7231 and 10.9231. We can conclude that the two mean test scores between two classes do not differ significantly since the range includes 0.
For question 3, we need to estimate the variance population and construct a confidence interval for these population parameters. A. Find a 95% confidence interval for the variance of population, and B. Interpret the results.
Using calculator or the formula, we can get the s squared. To solve this, we need to use chi-squared distribution with an n-1 degree of freedom. Simplify until you get the variance as the subject. Substitute n and s squared in the equation. Find this using chi-squared distribution table. And then you will get the answer.
To answer B, the 95% confidence interval for the variance of hours studied is 11.690 and 67.152.
Question 4. Estimate the variances of two populations and construct a 1 minus alpha% confidence interval for this ratio. Hence, A. Find a 95% confidence interval for the ratio of variances for two populations. B. Interpret the results. And C. Discuss your finding about the interval. Two populations we chose are class and test score. First, we need to split it up by class. Class A, the n is 7 and the variance is 209.33. For class B, the n is 5 and the variance is 126.8. To find the ratio of two variants, we use F distribution. We use n1 minus 1 and n2 minus 1, and then construct the F distribution until you get this. To answer question A, substitute the n and variance of class A and B in the equation. Solve until you get the ratio of two variances. For question B, to interpret this answer, we can say that it suggests that the variances between the test scores are equal because it includes 1. Thus, for question C, we can conclude that the equal variances that there is no statistically significant differences in the variances of test scores between class A and class B based on the sample.